Now, we are going to solve for the components of the vector, which is a result of the following algebraic operations on vectors. Using the given, for vector u, you have the components 4 and 1. For vector v, you have 0, 5. And for vector w, you have -3 and -3. The first here is to find out the resulting component of the vector for the operation u plus v. When you have u plus v, you're simply going to express, let's start with expressing them in their respective components. You will have here, for you, u is 4 and 1, plus your v is 0 and 5. To solve for the addition of the vectors here, we simply add the corresponding entries here. So you will have this situation, 4 plus 0, then 1 plus 5. In short, the result here would have the components 4 and 1 plus 5, which is 6. This is for u plus v. Alright, so that's what will happen here. For the next item, we have here v minus 3u. So let's start first with solving the scalar operation here of 3u. That's, yeah, I'm going to make it bolder, which is actually equal to 3 times the components of u, which is 4 and 1. This would mean that the components for 3u would be 12. That's 3 times 4, and you will have here 3. This is what you're going to subject to your operation here, because you will have v, which is 0 and 5, minus your 3u, which is 12 and 3. So doing that, you will have this result here. Again, it would be 0 minus 12, and then you will have, comma, 5 minus 3. So you will have the result here, which is equal to -12 and 2. This is for your v minus 3u. Right. Next here, we'll have the next operation. We have multiple operations now, but I would suggest you to start with this first. You have 5w. Okay, let's make this bolder. 5w. So we have a scalar multiplication here. 5 to your w, which is -3, -3 as well. This would mean you will have -15 and -15. Next is for our u minus 5w. Okay, which is our u is 4, 1, minus this result here, -15, -15, to which will give us this form, 4 minus -15, comma, 1 minus -15. Okay, so you will have the result here, which is 4 plus 15, that's 19, and 1 plus 15, that's 16. But we are not yet done, because the unknown here is, or what is asked is twice of that. So you will have twice the result of your u minus 5w. So you simply apply here the scalar of 2 to 19 and 16, which will give us a result of 38 and 32. All right. And finally, for our last, it's a little bit longer right now. Let's start with 2w. So you have 2w. You have 2 times -3 and -3. So you will have here -6 and -6. Right? You can even start with this, but this here. But let me just continue with u plus 2w. Our u is 4, 1. plus negative 6, negative 6 as a result of 2w. You have 4 plus negative 6, then 1 plus negative 6. So you will have result of negative 2, if I'm right, negative 2, and then, sorry, no parenthesis here, comma, negative 5. Let's start with 3v first. Let's continue with 3v. Your v is 0 and 5. This is 3, 0, and 5. So you will have 0 and 15. Okay? Now let's complete this one here. 3v minus twice u plus 2w. Okay? This is 0, 15 minus twice negative 2 and negative 5. You will have it here. Let me just use this first without considering the subtraction here. So you'll have 0, 15 minus negative 4 and negative 10. Notice that I did not distribute the minus sign here. So you will have 0 minus negative 4. So even without distributing the negative sign, you will end up the same result. You have 15 minus negative 10. So for the final result, for 3v minus twice u plus 2w, you will have positive 4 and positive 20, positive 25. Yeah, 25. 4, then 25. So this is the result now of the 4 different processes here pertaining on solving the components of a vector under these algebraic operations. Thank you for watching.